Hello, grade 7. This is Mrs. Lopez. Today we are working on a module 1 and lesson 7. In lesson 7, we are going to learn a new word, the constant of proportionality, and um, how unit rate relates to the constant of proportionality. So in the title itself, unit rate as the constant of proportionality, we can see that the unit rate and in previous lessons, we actually talked about that if relationship is proportional, if unit rate is constant, it does not change, right? So uh, the unit rate is the constant that shows proportional relationship. Therefore, unit rate is the constant of proportionality. The new word that you are learning today, constant of proportionality, is the old word that you already know, the unit rate. Okay. So the deer population. Wildlife conservationists are concerned that the deer population might not be constant across the national forest. They found that there were 144 deer in a 16 square mile area of the forest. In another part of the forest, they counted 117 deer in a 13 square mile area. In another part of the forest, they counted 216 deer in a 24 square mile plot of the forest. Do conservationists need to be worried? Well, first of all, just to back up a little bit, why would the conservationists be worried? Um, Sometimes we have overpopulation of deer. Sometimes we have less population of deer, and that's when they are going to think about, well, why is this happening? Are there too much hunting going on? Is there some sort of a disease? Yeah, are there many predators or something like that? So that's why the conservationists need to be worried. What is the population density of deer per square mile? So here we go with the math. Density deer per square mile. That's what we want to look for. So we will take the deer and we need to find um, what the population of deer per square mile is. So we will take the number of deer and divide it by the square miles. We have three different areas here. We have 144 deer in 16 square mile area. We have 17 deer in 13 square mile area and 216 in 24 square mile area. Okay, um, so 144 we are going to divide by 16. We will divide 117 by 13 and we will divide 216 by 24. When you do that, you will see that um, in each case, 144 I'm dividing by 16 right now, and I get 9. And 117 I'm dividing by 13 and getting 9. And 216 divided by 24 will also give me 9. So what is the unit rate of deer per 1 square mile? It is 9. Constant of proportionality is also going to be 9 because, as I explained at the very beginning, unit rate is the constant of proportionality because if it's constant, it does not change, it shows proportional relationship. Explain the meaning of the constant of proportionality in this problem. So what does that 9 mean? That means that in each square mile there are 9 deer. So we'll write there are 9 deer for each square mile. Use the unit rates of deer per square mile, y over x, to determine how many deer there are for every 207 square miles. Okay, so remember how we did tables, and since we are dividing, and our first column was x and the second column was y, because ratio shows the ordered pair and x always comes first, right? Um, and since we are dividing deer by the square mile, we want to um, put the deer as the y square mile, because we would always divide y by x. That's how generally we did all the work, right? So we have 1 square mile and 9 deer in each square mile, and we have 207 square mile here, 207 square miles here, and we need to see how many deer there are in that place. So if we are using our proportional relationship, which we are, and we are using our constant of proportionality, which is our unit rate, which is 9, we know that 1 times 9 is 9. So how can I find out the number of deer? I would just multiply the square miles by 9. So 207 times 9, and again notice I'm using parentheses as a multiplication operation, and you will see it a lot of times because that's how what we are going to do. So 207 times 9 is 1863. That tells us that there are 1863 deer in 207 square mile area. Okay, use the unit rate to determine the number of square miles in which you would find 486 deer. So if I continue this table, I'll just continue it here. Here I have square miles, and here I have deer, 1, 9. So right now I have, I'm sorry, you can't see that. Now I have 486 deer. That's where I'm going to put it in this column. 486, and I want to find out what that number is. Since 1 times 9 is 9, this number was multiplied by 9 to get 486. So how do I find what number was multiplied by 9? I would divide 486 by 9. And that's how I will find my x, which is the square miles. So I'm taking 486 and I'm dividing by 9, and I get 54. 54 square miles. Okay, let's move on. Kyle came home from school and told his mother that he volunteered to make cookies for the entire 7th grade. He needs 3 cookies for each of the 96 kids in his grade. Kyle and his mother determined that they can fit 36 cookies on 2 cookie sheets. Well, first of all, I find this situation very funny when when a child comes from school and says, "Hey, mom, I just need to make cookies for my entire team, 3 cookies for each child by tomorrow." It's just interesting situation. So let's see. How many cookies can fit on 1 cookie sheet? Well, first of all, we want to find out how many cookies there are in all to make. So we know that there are 3 cookies for each of the 96 kids. So how do I find the total number of cookies? I'm multiplying 96 by 3. 96 times 3, and that gives me 288 cookies. Okay. I know that there are 36 cookies in 2 cookie sheets. We want to see how many cookies can fit on 1 cookie sheet. So 36 cookies, I'm going to divide by 2 cookie sheets. And again, that is proportional relationship because if 36 fits into 2, I just need to divide by 2 to find the answer. So I have 18 cookies per each sheet of cookies. Okay, is the number of cookies proportional to the number of cookie sheets? Use the table to show the relationships. Okay, so we have on 1 sheet we have 18 cookies. On 2 we have 36. So we just need to continue the table. The constant of proportionality here is going to be 18, right? Because on one cookie sheet there are 18 cookies. 18 is going to be my constant of proportionality in this unit rate. Okay, so 1 times 18 will give us 18. 2 times 18 will give us 36. 3, let's do 4, 5, and 6. Let's see if that works. 3 times 18, 4 times 18, 5 times 18, 6 times 18. Okay, so 3 times 18 is going to give us 54. 4 times 18, 72. 5 times 18, 90. And 6 times 18 will give us 108. Okay, so we did not reach our 288. So let's see. Well, first of all, we know it is a proportional relationship, right? Because we have a constant unit rate of 18 cookie sheets per 18 cookies per sheet, and our constant of proportionality is 18. So the unit rate is 18, and the constant of proportionality is 18 as well. What does the constant of proportionality mean in this problem? There are 18 cookies in each cookie sheet. Okay. All right. So it takes to bake it takes 2 hours to bake 8 sheets of cookies. If Kyle and his mother begin baking at 4 p.m., when will they finish baking the cookies? Okay, so it takes 2 hours to bake 8 sheets. So it should take 1 hour for 4 sheets, right? Because we have 8 and we have 2 hours, so it's 4 sheets per hour. Okay, we know that. We don't know how many sheets we will need to make the entire 288 cookies. Let's see and extend this table to find out how many sheets we need. So we have 288 cookies altogether, and we know that that number was multiplied by 18, so we need to find out how many sheets we will need. So we need to divide 288 by 18, and that number is 16. All right, so we need 16 sheets. We have 4 sheets per hour. Okay, so what we need is 16 sheets in how many hours? Okay, well, to get 4, to get 16 from 4, we are going to again use proportional relationship. 4 times 4, so if you make a table again, 4 and 16, 4 times 4 will give us 16. So we have 1 hour here, so these are sheets and these are hours. Okay, so we need to multiply the hours by 4, and that will give us 4 hours. So it takes 4 hours to make 16 sheets of cookies. So if they're starting baking at 4 p.m., 4 p.m. plus 4 hours, that will give us 8 p.m. That's when they're going to finish baking the cookies. And that's granted that they don't have a break at all, right? So 4 hours straight of baking. So that was an interesting story here. Let's look at the next one. French cooking class. Kaylin want to prepare crepes for all of the students in their French class. The recipe makes 20 crepes with a certain amount of flour, milk, and 2 eggs. The girls aren't sure if they have enough eggs to make 50 crepes. Considering the amount of eggs necessary to make the crepes, what is the constant of proportionality? Okay, so crepes are those flat pancakes, the long ones. Um, they're a lot bigger. Okay. A recipe makes 20 crepes with a certain amount of flour, milk, and 2 eggs. Um, so if we look at the number of eggs, we know that there is 20 crepes with 2 eggs. So we want to see how many crepes we can make with 1 egg, right? So we need to find the number of crepes per 1 egg. So for that reason, we are going to divide crepes by the eggs, by 2 eggs. So it makes 10 crepes with 1 egg. Okay. What does the constant of proportionality mean? That's the constant of proportionality, 10, right? What does the constant of proportionality mean in the context of the problem? We can make 10 crepes with 1 egg. We can make 10 crepes with 1 egg. Again, constant of proportionality is the unit rate. Unit rate is the quantity of something per 1 unit of the other quantity. So we can make 10 crepes with 1 egg. And how many eggs are needed to make 50 crepes? Since I can make 1 egg with 10 crepes, we need 50 crepes. So again, we are making equivalent ratio here. We need to multiply 10 by 5 to make 50. So 1 times 5 will give us 5 eggs. All right, so the answer 5 eggs are needed to make 50 crepes. All right. So just basically, what we learned in this lesson is the constant of proportionality. We are using constant of proportionality as the unit rate. It's the same thing. So when we look for the unit rate, we look for constant of proportionality. We divide one quantity by another quantity. Normally it's y column. We are dividing by the x column. Go ahead and start on your homework or the problem set. And if you have questions, we will address them in the next class, or we will talk in the next class anyways. Good luck.